Hi, I always face these kind of problems when it comes to connecting an LDR circuit with a AC light bulb. It always starts to flicker because the turning on point and off point are nearly the same at some point. So in this video I will figure out how to solve this problem and I will show you exactly how to do that. So let's get started. So here in this you can see that here we have LDR connected. So when enough darkness comes, the light turns on, and when enough light falls, the light turns off. But you see, the light doesn't flicker at some point, it turns on and off very precisely. To solve this problem, I have made a comparator. I have made a comparator for that. Now, what is a comparator? A comparator is a op-amp circuit which compares the voltage. So when when the given input voltage is higher than the reference voltage, the output goes high, and when the input voltage is less than the reference voltage, the output goes low. So here I have taken a LM358 op-amp IC, and you can see that I have connected a 1 kilo ohm resistor in the input terminal and a feedback resistor of 10 kilo ohm to the non-inverting input, and the inverting input is connected with a potentiometer to set the reference voltage. Now this potentiometer is used to set the reference voltage, hence we can adjust the sensitivity of this circuit. Now as we know that when the output of the comparator goes high, it tries to stay there, and when we try to pull it to low, we must provide some amount of difference between the reference and the input pin. So the turning on point and off point are not the same, hence we can evade that flickering in this circuit. Now let me explain the rest of the circuit here. Here I have just connected a debugging LED which is not really required, so I will just remove that. This circuit requires two batteries to be powered. So one battery is just not enough. Here I have a 12-volt relay as shown in the previous videos, an NPN transistor, a op-amp IC with a 10 kilo ohm feedback resistance, and a 1 kilo ohm input resistance. So R2 is 10 kilo ohm and R1 is 1 kilo ohm, so our gain is 10, and it is a non-inverting comparator. Here we have a 7805 voltage regulator, a 10 kilo ohm LDR, and a ballast circuit. For that I have connected two 5 kilo ohm resistances in series to get a 10 kilo ohm resistance, and here I have a DC-DC boost converter to step up the 9 volts to 12 volts, up to 12 volts, to control this relay. Now you can of course use a 5-volt relay so that you would be able to make this circuit without using this step up converter, just by using this 7805 IC. And if you have any difficulties understanding how this LDR circuit works, just watch one of my previous videos and you will probably figure it out on your own. It is not that complicated. So thanks for watching. I see you in the next video.